बाबा, तर मी थोड्या वेळाने करतो. बाबा, खुर्ची धुवायची आहे ना, आतमध्ये करतो. हा, पण मी करतो. तुमचं झालं की सांग. हा, मी करतो तर.
So here we are to my first YouTube live, and we start with a lesson on quadratic equations as a first lesson. Now, there's a reason behind me taking up this topic. Number one, the lesson is very simple, but still, I have seen in last 26 years students do make mistakes. Mistakes happen in finding in putting the proper sign for the trinomial. Mistakes happen in remembering the formulas which are based on nature of the roots. Mistakes happen in deciding whether they need to solve that problem by factorization method or by formula method. So that is all that we are going to cover. I've tried to cover the entire quadratic equations with irrespective of whether you belong to the CBSE board or the ICSE board or the SSC board. Questions selected over here are from the past papers of the three curriculums. Okay. Um, so let's begin. Let me start with introducing myself. So hello everyone. Welcome to the Concept Booster lesson number one. Concept Booster class number one. That is quadratic equations. Myself, Simant Mulye, a mathematics educator for last 26 years, and I have helped over 4,000 students in last 26 years and have conducted more than 12,000 sessions in 5 years across 8 countries. This presentation is brought to you by Simanti Tutorials. So let's begin. So when we are doing quadratic equations, you should first know what a quadratic equation is. And so you should first know what a quadratic equation is. Okay. So
Okay. Okay. So,
yes, kindly excuse me. It's been my first attempt at going live on YouTube. Um, though I have been teaching online, but that system is different, where we have our own learning management system and we conduct our classes on the platform. YouTube Live is something that I'm doing it for the first time. I'm just going to have one final look at whether things are fine. Uh,
fine.
yes, they are.
Fine.
Let's begin. So, grade 10 mathematics. This is concept booster number one, quadratic equations, by Simant Mulye, a mathematics educator for last 26 years. And this presentation is brought to you by Simanti Tutorials. I repeated that once again because I realized that I wasn't sharing, which is very important. Let's start. What is a quadratic equation? So, a quadratic equation is an equation which is written in a standard form as ax square plus bx plus c equals to 0, where a, b, c are real numbers. A is not equal to 0 because if a becomes 0, then this term will not be there, and so this will become a linear equation. So it's very important that the any equation in the form of ax square plus bx plus c equals to 0 is a quadratic equation, provided a will not be equal to 0, and a, b, c are real numbers. Real numbers means any number uh, which is not real. Not real means square root of negative numbers, say minus 11. You haven't studied such numbers till date. So these are not real numbers. So real number would be square root of 11. Yes, it's a real. Pi is a real number. Let me not get into more detail about real numbers. I will have another session for real numbers some other time. I have written some examples over here for quadratic equation. X square minus 5x plus 6 equals to 0. 2x square plus 3x minus 4 equals to 0. It's a quadratic equation because the highest power of x is 2. The word quad itself means square, and that's why it is called quadratic. I want you to quickly give me an example for an equation which is not quadratic. Please type that in the chat box so that I will get to know that you are there live. Or I'm going to give you one equation. Or I'm going to give you one equation. Say I'm going to give you one equation. 3x plus 4. Say, I'm going to give you one equation. 3x plus 4 equal to 0. Is this a quadratic equation? You can type in yes or y for yes and n for no uh, in the chat box. Another one would be x cube plus 2x square minus 3x plus 7 equals to 0. Here, you need to tell me whether x cube plus 2x square minus 3x plus 7 equal to 0 is a quadratic equation. If it is not, you will tell me why it is not a quadratic equation. So n for no and the reason behind that. Please type that in the chat box. If it is yes, please type yes. Let's move ahead. Now this one is quite an interesting question. It's an activity based question. So such questions are basically asked in SSC board. The question says, I am a quadratic equation. My standard form is, do you remember the standard form which we did earlier? Ax square plus bx plus c equals to 0. Yes, this is a standard form. Next step is my roots are 5 and 12. Now you need to know what is the meaning of roots. Roots and solution means the same. So let me clarify by giving you an example. I'm taking a linear equation x plus 4 equals to 5. Now x equal to 1 is a root of this linear equation. Why? Because if I put x equal to 1 in the equation, it will satisfy the equation. So we have 5 equals to 5, and that makes it a root or a solution. So in this question, when they say my roots are 5 and 12, that means values of x are 5 and 12. Now, further, they are saying sum of my roots is, so you simply add 5 and 12 in this case, which is 17. Product of my roots is 5 times 12, so that is 60. My quadratic equation is, you need to know the formula for this. The formula is x square minus sum of the roots times x plus product equals to 0. So the equation is going to be x square minus sum of the roots is 17 x plus 60 equals to 0. So I'm going to write that part over here, x square minus 17x to 0. Simple, right? The only thing that you need to remember is this formula. And you apply this formula when you know some of the roots and the product of the roots. Or rather, you can find them out if you know the roots. Okay, let's move to the next question. The next question is asking us which one is the quadratic equation. Now, understand what I did. The first slide, I told you what a quadratic equation was. A quadratic equation has the highest power to be 2. Now, when I say highest power, it is important that you simplify the entire equation, and then the highest power of the variable is 2, or the degree of the equation is 2. Degree means the highest power of the variable. So in this case, what we are supposed to do is we are supposed to simplify each of the equations and then check uh, whether the highest power is 2 or not. There's one more thing that you can do. 5 upon x minus 3 equals to x square. I can write this as 5x raised to minus 1 minus 3 minus x square equals to 0. We can rearrange this as, if I multiply by minus 1, we will get minus 5 x raised to minus 1 plus 3 plus x square equals to 0. Rearrange the terms. X square minus 5x raised to minus 1 plus 3 equals to 0. Now, highest power is 2. So you may say that this is a quadratic equation. Here I have not simplified, but I have simply used the rules of indices, where I took the term, the variable in the denominator to the numerator. And so it became raised to minus 1. Now, is this a quadratic equation? No, simply because here we need to compare it with ax square plus bx plus c equals to 0. Now, is this equation over here in the form of ax square plus bx plus c? No. The middle term variable is x. For us, it is x raised to minus 1. And so it is not a quadratic equation. There are two ways. Either you do this or you simplify it completely. Let me show you what I mean by simplify completely. I'm going to do that part also. 5 upon x minus 3 equals to x square. I'm going to multiply each term by x. So x times 5 upon x minus 3 times x equals x square times x. So the x gets cancelled. We have 5 minus 3x equals to x cube. Now if I collect all the terms to one side of equation, this will become x cube plus 3x minus 5 equals to 0. Now, is the highest power of the variable 2? No, it is not. It's 3. And therefore, it is not a quadratic equation. This is what I meant by complete simplification. You can either do it in this manner or you can use exponents. You can take this uh, variable in the denominator to the numerator. Apply the law of exponent. This will become x raised to minus 1. And then if you compare it, it is not in that form of ax square plus bx plus c equals to 0. And so it is not a quadratic equation. Let's have a look at second one. X times x plus 5 equals to 2. So we multiply the brackets. Now, usually students make a mistake over here. What they do is, while multiplying, they just multiply the first two terms and they forget to multiply x with the second term in the bracket. Now, I'll give you an analogy for this. Try to remember this. The analogy goes like this. This is one family, x plus 5. Let's say these are two members, these are two terms. So uh, we can call this as two members in the family. Now, if a family member, let's say daddy, gets an ice cream, he's going to get an ice cream for both the members, right? For all the members. Likewise, let's say this term which is there outside, when you open the brackets, you multiply with all the terms within the bracket. So x times x is x square plus 5x. 2 goes to the left, so that becomes minus 2 equals to 0. Now, is this a quadratic equation? Yes, it is. If you compare it with ax square plus bx plus c equals to 0, yes, it is in the form. You don't have to compare, but you need to check whether it is in the form of ax square plus bx plus c equals to 0. And it is in that form, and therefore we can say the equation is a quadratic equation. Is in the form, I should be writing, is in the form of ax square plus bx plus c equals to 0. Now the third one, n minus 1 equals to 2n. I'm going to collect all the terms to the right hand side. So 2n minus n plus 1 equals to 0. So n plus 1 equals to 0. Is the highest power of this equation 2? No, it is not. Therefore, it is equation. And now we are left out with one more. Let's have a look at that one. It is 1 upon x square times x plus 2 equals to x. We can cross multiply. So we can take this x square. Actually, it is you multiply by x square on both the sides. So x times x square is equal to x plus 2. This x square and x square that you multiply gets cancelled. So x plus 2 is equal to x cube. And now you collect both these terms to the right hand side. And we get x cube minus x minus 2 equals to 0. Is it in the form of ax square ax square plus bx plus c equals to 0? If it is not, then this is not a quadratic equation. And it is not. The highest power is 3, and uh, highest power is 3 for the variable x. For an equation to be quadratic, the highest power of the variable should be 2. And so we say this is not a quadratic equation. Let's move further. Solve the following quadratic equation for x. Square root 3x square plus 10x plus 7 root 3 equals to 0. Now, um, so we are going to solve this by factorization method. Now here they have not said whether you have to do it by factorization method or by formula method. So usually what we do is we check whether it can be factorized quite easily. If the factors are quite obvious or you are able to find them quickly and they haven't, if you can find it quickly, go ahead by factorization. If you find it challenging, the numbers are very large and they have not mentioned the method, do it by formula method. In this case, I'm going to do it by factorization method. How do we go about it? So it's root 3 times 7 root 3. So root 3 times 7 root 3 into root 3 is 3, 7 times 3 is 21. So we need to find factors of 21 to get the middle term, positive 10. Now, usually always start from 1. 1 times 21. The product is 21, right? The product is positive So understand both factors should be either positive or both factors should be negative. How do we decide what would be the sign of both the factors? By looking at the middle term. The middle term is positive, and therefore both factors are going to be positive. Now, when you add these plus 1 plus 21, it gives us plus 22 and not plus 10. So we discard this pair. 2. 2 is not a factor of 21. 3. 3 times 7. I'm going to put positive to both the sign, both the terms, both the factors. 3 times 7 is 21, plus 3 plus 7 is plus 10, and that's what we need. So we are going to split the middle term as 3x plus 7x plus 7 times root 3 equals to 0. This is root 3x square. Now from these first two terms, the common factor is root 3x. So within the bracket, we get x plus root 3. If you find this challenging or you don't understand how root 3x came out as a common factor, then very quickly I'm going to show it to you. We can write the first term as root 3 times x. You divide it by the second term is 3x. So we can write this as root 3 times root 3. Root 3 times root 3 is 3 and x. Root 3 can be cancelled out. That's the reason I took root 3 as a common factor. X can be cancelled out. So I took x as a common factor. So the terms within the brackets are x plus root 3. Same thing, if I do it here, we get 7 bracket x plus root 3 equals to 0. A common mistake done by students is they if they make a sign if they make a mistake in this in one of the signs of these two terms of the factors. I have seen students writing the second bracket same as the first one without cross checking for whether their signs were proper or not, and that's where they go wrong. So never use shortcuts. What I mean by that is always solve it in your mind by applying the rules which are there. Do not go as per the first bracket is x plus root 3. So we would write the second bracket also as x plus root 3. If there would have been these two terms would have been different, there is a possibility of you making a mistake, which if you apply the rules, you'll be very quickly be able to identify your mistake. So let's move ahead. X plus root 3 is a common factor. Within the bracket, we get root 3x plus 7 equals to 0. So x plus root 3 equals to 0, or root 3x plus 7 equals to 0, and therefore we have x equals to negative root 3 or x equal to minus 7 upon root 3. Now we have found values of x. That means these are the solutions of the given quadratic equation. So we can say solution is x equals negative root 3 or x equals minus 7 upon root 3. You can also write the same answer as solution set. If you write solution is, that's fine. Or you can write solution set. If you say set, you need to put in a curly bracket minus root 3 comma minus 7 upon root 3. Let's move to the next question quickly. Okay. So we move further where we need to identify the nature of the roots. Now, nature of the roots help us to identify number one, whether the roots are real and equal. Number two, whether the roots are distinct and real. Distinct means two different values, and the roots are not real. For that, we need to know the value of the discriminant. The discriminant is d is equal to b square minus 4ac. So if d is greater than 0, then the roots are going to be distinct and real. If value of d is going to be equal to 0, then the roots are going to be equal. Simple way to remember: equal to 0, equal roots. Greater than 0, two roots. Less than 0, no real root. And how do you remember the value of, or the formula for the discriminant? B square minus 4ac. Our quadratic equation is ax square plus bx plus c equals to 0. So the discriminant is square of the middle term, b square, minus 4, that's a constant, product of the coefficient of x square and the constant. That's the value of the discriminant d. Once again, we will revise. D is equal to 0, roots are real and equal. D is greater than 0, roots are real and distinct, matlab two different roots. D is less than 0, roots are not real. So we are going to use this to solve the equations, the next question. Question says the given quadratic equation 3x square plus root 7x plus 2 equal to 0 has two equal roots, or two distinct real roots, or more than two real roots, or no real root. So when they ask you how many roots are there, or how are the roots, whether the roots are real or not real, that means you need to find out the value of b square minus 4ac. So let's start. I'm going to start by comparing with ax square plus bx plus c equals to 0. So we get a as 3, the coefficient of x squared term, b as root 7, and c as 2. A is 3, b is root 7, and c as 2. So discriminant d is equal to b square minus 4ac. That's root 7 the whole square minus 4 into 3 into 2. Root 7 the whole square is 7 minus 24, which is negative 17. So value of d is less than 0. So when it is less than 0, roots are not real. So the correct option would be D. Simple, right? Would you like to tell me um, one equation, or rather one example of a quadratic equation which has just one root? Would you like to give it a try? Let me give you one. X square minus 4x plus 4 equals to 0. Now this one, if you find out b square minus 4ac for this equation, this is going to be minus 4 square minus 4 into 1 into 4. 16 minus 16 is 0. When d is equal to 0, that means roots are real and equal. When I say roots are real and equal, that means there is just one root. Think about an equation where the roots are uh, where the roots will be real and distinct. Now this one, option C, do you can you think of an example where you will get more than two real roots? This question will be for CBSE board, where they give you the graph and they ask you to identify how many solutions or how many roots does this graph have. Try to think. Let's move ahead. Okay. Now solve the following quadratic equation: 2x square minus 5x minus 4 equals to 0. Give your answer correct to three significant figures. Over here, I'm going to do it by formula method. For CBSE and SSC board, you need to leave the answer um, as a third. Further, I'm going to help use the tables, the mathematical tables, to get the answer to three significant figures, which will be for the ICSE board. So let's start. Compare 2x square minus 5x minus 4 equals to 0 with ax square plus bx plus c equals to 0. We get a is 2, b is minus 5, and c is minus 4. I will find out the value of b square minus 4ac separately. So minus 5 the whole square minus 4 into 2 into minus 4, that's 25, plus 32, which is 57. Once you have this, you can find out, you can apply the formula. So this is negative b plus minus square root of b square minus 4ac upon 2a. B is negative 5, so this is going to be minus of minus 5 plus minus. Now I can substitute the value for b square minus 4ac directly. That's root 57 upon 2 times 2. So this is 5 plus minus root 57 upon 4. Now if you are a CBSE or SSC board student, you can leave the answer as x equals to 5 plus root 57 upon 4, or x equals to 5 minus root 57 upon 4. For ICSE, I'm going to help you find the value of root 57 using the table. So what we do is x equals to 5 plus, I'm going to write this as 5.7 into 10 upon 4. 5 minus square root of 5.7 into 10 upon 4. Now, 5.7 times 10 is 57. That's the reason why I have done that. Now, important, why did I do it in this manner? Because if you have a look at the tables, in the square root tables, they start from 1.0 till 9.9, right? So by expressing this in the form of a number between 1.0 to 9.9, we can start using the tables. That's the reason. Now this becomes x equals to 5 plus, we can write this as root 5.7 times root 10 upon 4, or x equals to 5 minus root 5.7 into root 10 upon 4. So 5 plus, how much is root 5.7? So I'm going to look into the table, the row 5.7 and the column 0. The number that comes under row, in the row 5.7 and under column 0 is 2.387, and square root of 10. Now for square root of 10, what I'm going to do is I'm going to come to the row 9.9, and the ninth column, the number in the 9.9 row under column 9, that is 3.161, and to that I add the column in the mean difference under 1. The number over there is 0. So 3.161 plus 0 is 3.161, or x equals to 5 minus 2.387 into 3.161 upon 4. Now comes the challenge. Usually, I have seen students of ICSC, they put a lot of time in multiplying this. What if you do not have time? So, in that case, I'm very quickly going to tell you how to arrive at an approximate answer. It is going to be an approximate answer that will help you in case um, you are short of time to complete your paper. If you have the time, yes, definitely you can multiply this and perform the entire operation and then divide by 4. I'm going to get an approximate answer to this 5 plus. This will be 2.4 times 3.2 divided by 4, or x equals to 5 minus 2.4 into 3.2 divided by 4. 24 times 3 is 72. 24 times 2 is 48. 720 plus 48 is 768. This is 7.68 plus 5. That's 12.68. 12.68 divided by 4 is 3s are 12, 4, 3.17, or x equals to 7.68. 5 minus 7.68 is minus 2.68. So this is minus 0.670. That's our answer. It was fast, right? So once again, I will mention, if you are short of time, you can do an approximation and get the answer in this way. If you have the time, multiply this, perform the entire operation by adding 5, and then divide by 4. Let's move further. I hope you liked that trick. If you want to know how to uh, get an approximations, I will be making a video. You can have a look at that. I will try to put in detail all the rules for approximations, and you can always use them, not just for your grade 10 exams, but at any point of time in life. So here we are. We have a word problem. The product of Rehan's age in years 5 years ago and his age 7 years from now is one more than twice his present age. Find his present age. So we always start by assuming a variable x for what they have asked us to find. So I'm going to start by assuming let Rehan's present age be x years. 5 years ago, that means 5 years behind. So 5 years ago, Rehan's age was. If today you are 12 years old, sorry, if today you are 15 years old, 5 years ago you were 15 minus 5, that's 10. So if Rehan is X years today. His age 5 years ago was X minus 5. The same rule is applicable to Rehan also. 7 years from now, Rehan age will be X plus 7. If you're 15 years today, 7 years from now, you will be 15 plus 7 years old. So same rule is applicable to Rehan also, who is X years today. So his age 7 years from now will be X plus 7 years. Now we need to apply the conditions which are given. They're saying product of Rehan's age 5 years ago and 7 years from now. Product means you multiply by given condition x minus 5 into x plus 7 is one more, so that's plus 1, twice is present age. Twice means 2 times present age is x, so 2x plus 1. You expand the brackets, so that will become x times x plus 7, first term multiplied by the second bracket. Then you put the sign which is there between the two terms in the first bracket. In this case it's negative 5 times x plus 7 equals to 2x plus 1. Now you remember the analogy which I gave you. if you if daddy gets an ice cream, he will get it for all the members in the family. So when you open the bracket, you multiply with all the terms within the bracket. So this is going to be x times x square plus 7x minus 5x minus 35 minus 2x minus 1 equals to 0. I collected the terms on the right hand side also to the left hand side. So this is going to be x square, 7x minus 5x is 2x, 2x minus 2x gets cancelled, minus 35 minus 1 is minus 36 equals to 0. So x square minus 36 is equal to 0. X square is equal to 36. X equal to square root of 36. And so x is equal to plus minus 6. Now, x in this case is the age of Rehan. We know that age cannot be negative. And therefore, we can say x equal to 6 years is Rehan's present age. Okay, so let's move further. We now have 7 more minutes, and that's the last question. So I have tried to cover most of the topics either in the question form or through my explanation. If you feel that something has been missed out, please um, share it in the chat. Let me know, and I will help you with that problem. If you have any other problem that needs to be that where you need support, do let me know. I will be more than glad to help you. Also, I also plan to conduct these booster series every Sunday on at 5 p.m. So next session will be on linear equations. So if you need help, you can join. You can join that. I will be trying to get as many different questions that covers curriculum for most of the for all the boards, that is CBSE, SSE, and ICSE, and hope that will be helpful to you. I had also promised that there will be a worksheet, so you can check out in the chat after the class. I will share the link, and you can get your worksheet where you can practice questions over there. Now let's move to the last question, that is find the roots of the quadratic equation by completing the square method. So the equation is 2x squared plus x minus 4 equals to 0. Most important thing is the coefficient of x squared term has to be 1. So I'm going to divide by 2, each term by 2. So we get x squared plus x upon 2 minus 4 upon 2 is 2 equals 0 upon 2, which is 0. Once you do this, you take the constant term to the right hand side. So this will become x squared plus x upon 2 equals to 2. And now comes the turn of applying the formula. So the third term formula is half into coefficient of x, the whole square. Coefficient of x in this case is half. It's 1 by 2, right? So this is going to be half into coefficient of x is half the whole square. This is 1 by 4 the whole square, so that's 1 by 16. And so we can, what we do is this third term needs to be added on both sides of the equation. X squared plus x upon 2 plus 1 by 16 equals to 2 plus 1 by 16. Why this? Why do we add? The name of the method is completing the square method. So this formula for the third term gives us a term that converts this equation on the left hand side to be a perfect square. When I say perfect square, that means it will be either in the form of a plus b the whole square or a minus b the whole square. In this case, it is going to be a plus b the whole square simply because the middle term sign is positive. If the middle term sign would have been negative, then it would have been a perfect square for a minus b the whole square. So it's a perfect square of, how do you identify that? Square root of x square is x. Square root of 1 upon 16 is 1 upon 4. The middle term sign is positive. So it's x plus 1 upon 4 the whole square equals to. We can equalize the denominators on the right hand side. So x plus 1 upon 4, the whole square is equal to 32 plus 1, 33 upon 16. We can take square to the other side. And so this will become x plus 1 upon 4 equals to square root of 33 upon 16. And so this becomes x plus 1 upon 4 equals to plus minus root 33 upon 4. Take 1 upon 4 to the other side, so we get minus 1 upon 4 plus minus root 33 upon 4. And so we have minus 1 plus root 33 upon 4, or x equals to minus 1 minus root 33 upon 4. So in the end, we can write solution set is minus 1 plus root 33 upon 4, or sorry, solution set equal to, I in a set the elements are separated by putting a comma between the elements, and so let me erase this. This is minus 1 minus root 33 upon 4. You can either write it as solution set, or solution is individually minus 1 plus root 33 upon 4, or x equal to minus 1 minus root 33 upon 4. With this, we have come to the end of the booster lesson number 1 that I conducted for the first time on YouTube Live. That is on quadratic equations for grade 10. I tried to get questions from the past papers of all the curriculums, ICSE, CBSE, and SSC. I just did it from one paper that covered most of the topic. Um, Hopefully, by having a look at these questions and practicing some more questions, it will prepare you for quadratic equations. Remember, it's not about solving this one question. One or two questions is not what is going to help you. This is a support which is being provided by Simant tutorials. Finally, you have to practice and get better, get support of your teachers, get better at math. That will boost your confidence. Next Sunday, we will have another session on linear equations. So, hope to see you there. Have a great evening.